My name is Arno Penzias. I came to the United States as a child refugee from Nazi Germany in 1940. I attended college at City College of New York, where I studied physics. From there, I got married, spent 2 years in the U.S. Army Signal Corps, and then began pursuing my PhD at Columbia University. The project I was involved with used a large 20-foot horn-shaped antenna that was designed by Bell Labs in 1960. Its original purpose was to collect and amplify radio signals to send them long distances. It was to be used with an early satellite system called ECHO. However, ECHO became obsolete a few years later due to the Tesla satellite. With the antenna no longer having commercial use, it was now available to be used for research. My associate for this project was Robert Wilson. Robert came to work for Bell Labs after studying at Caltech. He was a radio astronomer just like me. Upon his employment at Bell Labs, we were both involved in separate projects, but in 1963 we decided to team up and use the 20-foot horn-shaped antenna for radio astronomy research. What we were seeking when we began our project was to map radio signals from the Milky Way. We wanted to analyze the radio signals from the spaces between galaxies. However, when we began our research, we encountered a constant noise. We needed to remove the static so we could be able to conduct our experiments. In trying to remove the noise, we looked to eliminate any possible cause. We removed the effects of radar and radio broadcasting, cooled the heart of the receiver with liquid helium, pointed the antenna towards New York City to rule out urban interference. We even removed pigeons from the horn and cleaned out all of their pigeon poop. After removing every possible form of interference, the noise still persisted. The noise was a uniform microwave range signal with a wavelength of 7.35 centimeters and came from all directions. Around the same time as mine and Robert's project, Robert Dick, a physicist at Princeton University, had theorized that if the universe was created according to the Big Bang Theory, then a low-level radiation would be found throughout the universe. We reached out to him with our discovery, and he confirmed that we had in fact found the radiation that he theorized about. Our project took place on a hilltop in Homedale, New Jersey, which is where the giant 20-foot horn antenna is located. Many significant events happened in the early 1960s around the same time as we were performing our project. In 1963, John F. Kennedy was assassinated and Lyndon B. Johnson became President of the United States. Also in 1963, the USSR became the first nation to put a woman in space. In 1964, Beatlemania came to America and President Johnson signed in the Civil Rights Act of 1964. Around the same time, the Vietnam War began, which brought along with it a large anti-war movement. In 1965, the Voting Rights Act was passed, which ensured African Americans the right to vote. Since Robert and I were both radio astronomers and physicists, we tackled the research and experiments together. However, there's one role that I had in the project that I'm not very proud of. As I mentioned earlier, one of the possible causes of what we thought was interference was pigeons that had set up their nest in the horn. We captured and removed the pigeons several times, but they kept coming back. Ultimately, we decided that the most humane thing to do was to get a shotgun and shoot them at a very close range to kill them instantly. It's not something I'm happy about, but it seemed to be the only solution at the time. The noise that Robert Wilson and I discovered had a major impact on the physics community. It ended up being cosmic microwave background radiation, CMB. CMB is approximately 3 degrees Kelvin or negative 270 degrees Celsius, and it is uniformly perceptible in all directions. This radiation points to an extremely hot and violent explosion that the Big Bang Theory suggests about the start of the universe. Ultimately, our discovery of cosmic microwave background radiation was the start of modern cosmology. Much of the equipment that we used for our project has been preserved. The giant horn antenna still sits upon the same hilltop in Homedale, New Jersey, and was designated as a national landmark in 1990. The radio receiver and its calibration system I sent to the Deutsches Museum of Munich, Germany, which is the city of my birth. As for the metal trap that we used to catch the pigeons, It can be seen in the Exploring the Universe exhibit at the Smithsonian Institute's National Air and Space Museum.